Public safety is the top priority of the United States Army Corps of Engineers, and the Corps is committed to reducing risk in southeastern Louisiana by completing the Greater New Orleans Hurricane and Storm Damage Risk Reduction System in 2011. That system includes levees, flood walls, pump stations, and floodgates that will reduce risk from 100-year level storm surge. These congressionally authorized improvements in the Inner Harbor Navigation Canal will better protect the residents of New Orleans East, Metro New Orleans, the 9th Ward, and St. Bernard Parish. The Inner Harbor Navigation Canal, or IHNC, links Lake Pontchartrain, the Mississippi River, the Gulf Intracoastal Waterway, and the Mississippi River Gulf Outlet. The IHNC's interior system will be better protected by two lines of defense. The primary defense will be the new Lake-Borne Surge Barrier and the new Seabrook Gate. The secondary defense will be the repaired and improved interior levees and flood walls along the IHNC corridor. It's important to note that even with the improved storm damage reduction system in place, there will always be residual risk to surrounding communities that can be further reduced through zoning, building codes, insurance, and evacuation. One of the new structures in the New Orleans Hurricane and Storm Damage Risk Reduction System is a surge barrier across the marsh west of Lake Borgne. This barrier will help protect some of the region's most vulnerable areas from surge generated through the Gulf of Mexico and Lake Borgne. A 10,000-foot barrier, almost 2 miles long, is being constructed near the confluence of the Gulf Intracoastal Waterway and the Mississippi River Gulf Outlet. The barrier includes a sector gate, a barge gate, and a vertical lift gate. The Mississippi River Gulf Outlet is now decommissioned. This cutaway shows how the deep portion of the channel was partially filled using rock and sand to serve as the foundation for the new flood wall. The barrier's flood wall is made up of circular, reinforced, spun-cast concrete piles that are driven more than 100 feet deep. Grout is placed in between each 66-inch concrete pile, along with two smaller 18-inch closure piles to fill the gap. On the protected or populated side of the barrier, 36-inch batter piles are driven at an angle to support the flood wall. These angled piles reach nearly 200 feet deep for added stability. Each of the 66-inch piles is filled with steel reinforcing bars and concrete. A concrete cap and parapet wall top off the pile system, providing a roadway for operations and maintenance crews. The Lake Borgne Surge Barrier is the largest design-build civil works project in the history of the Army Corps of Engineers, and it will be complete in 2011. To the north at Bayou Bienvenue, a lift gate is built for commercial fishing and recreational boat access to Lake Borgne. Additional soil dredging allows a barge with a large crane to drive piles deep into the mud to support the foundation. A large cofferdam is placed around the piles, and water conveyance pipes are inserted to allow tidal flows to pass during construction. A slab of Tremy concrete, a special mixture for use underwater, is poured through pipes to seal off the bottom of the foundation. Then the water is removed. The pile tips are cut off, and the floodgate foundation is poured. A concrete superstructure monolith is built. Once construction of the massive barrier is complete, a steel gate frame for the lift gate and an access bridge are constructed. Then the water conveyance pipes are removed, and the cofferdam is rewatered. Final steps include the construction of a control house on the protected side of the Bayou Bienvenue floodgate, placement of the lift gate leaf, and installation of the dolphins and guide walls to protect the structure from boat collisions. Further north, where the Lake Borgne Barrier crosses the Gulf Intracoastal Waterway, Two 150-foot-wide navigation lanes constitute the gate system for this waterway. Construction of the barge gate foundation requires driving concrete piles, installing the cofferdam, and placing sheet piles to subdivide the Tremy concrete pours. Reinforcement slabs are poured. The monolith structures are constructed. Water is allowed back into the cofferdam, and the cofferdam is removed. Construction then begins on the sector gate. Piles are driven and a cofferdam is installed. Sheet piles subdivide the Tremy pours, and the concrete sill is poured. The pile tips are cut off. The reinforcement slabs are poured, and the cofferdam is rewatered and removed. Next, the steel sector gate and maintenance bulkheads are installed, and the concrete barge gate is floated into place. A safe house with generators is built, along with an elevated access ramp from the New Orleans East back levees. This safe house also contains the gate controls. Navigational sector and lift gates in the Seabrook area will reduce storm surge impacts from Lake Pontchartrain. The first step of construction is filling the scour hole. Then a cofferdam is built and sections of connecting levee T-walls are constructed. Sheet piles are placed and piles are driven 75 feet below ground. The concrete Tremy layer is poured to seal the cofferdam, and then the water is removed prior to the start of gate construction. The pile tips are cut off and the concrete sill is poured. The next steps in this process include building the concrete enclosure structure and installing the gates. Water is allowed back into the cofferdam. The cofferdam is then removed, and the guide walls are placed. Stone riprap is put around the structures to provide protection against the water and waves. These Seabrook gates work in concert with the new Lake-borne barrier to reduce risk in the IHNC from 100-year storm surge levels. Since Hurricane Katrina, the U.S. Army Corps of Engineers has repaired, restored, and made improvements to the hurricane and storm damage risk reduction system in the Inner Harbor Navigation Canal area and across the region. Pump stations have been repaired and improved, and so have levees, gates, and flood walls. Flood walls across the system have been reinforced, including replacing many of the eye walls with stronger T-walls. In the lower 9th Ward, the new T-walls stand 15 feet above sea level. The flood walls also now have scour pads, or concrete slabs, behind them to reduce erosion caused by overtopping. And the levees and flood walls are armored, and transition points between them strengthened. As an additional safety measure, the Corps used a technique called deep soil mixing to stabilize the existing eye wall foundations along the west wall near Lake Pontchartrain. A drill loosened the soil around an auger. As the auger rose, cement slurry was pumped in and mixed with the soil to form a stable column that will help the flood wall resist overturning in high water during a storm event. Along the east wall, the Corps added relief wells. These relief wells stabilize the ground by draining excess water from the subsurface sand layer. As water rises during a storm, the wells relieve the pressure behind levees and flood walls, collecting and moving the excess water to the storm drainage system. The new Lake-borne surge barrier is situated on the east side of the Inner Harbor Navigation Canal system and protects against storm surge from the east. When a storm approaches, the operator first goes to the Bayou Bienvenue location. Once inside the control house, the operator begins to lower the lift gate to block pending storm surge coming through Lake Borgne. The operator then goes to the control house on the north bank of the Gulf Intracoastal Waterway. The control house is built to provide protection from the storm, and it contains backup generators to provide power to operate the gates. In the control room, windows look out on the barge and sector gates at the Gulf Intracoastal Waterway. These windows provide a clear view as the operator watches the gates close. The new Seabrook gates will protect the IHNC from storm surge coming from the north off of Lake Pontchartrain. An operator drives to the control house as the storm approaches, gaining access to the control house from the protected or inhabited side on the west wall of the IHNC. Backup generators are located in the Seabrook control house to supply power to the gates. In the control room, the operator begins lowering the lift gates and closing the sector gate. The closing of these gates, in conjunction with the gates at the Lake Borgne surge barrier, completes the system that will help reduce the risk of surge damage in New Orleans East, Metro New Orleans, the 9th Ward, and St. Bernard Parish. The Army Corps of Engineers' #1 priority is public safety. And the Corps is using innovative practices and leveraging both internal and external expertise to complete its mission of providing 100-year level risk reduction in 2011. And together, with individuals and public leaders working to further reduce risk in their communities, we will make Greater New Orleans safer than it has ever been before.